Oh, great. It is the big one. Fair enough, fair enough. Was it? Like, so I wanted to stress it, but then I think that we could too, yeah. So that's not, I don't think I'm close to it. I like, it's like concentrated, like, if you're afraid of it, yeah. Those are the markers.
So, what? All right, go ahead and log into Bora. And get to a spot where you want to take quiz 3. Log in. Right. So exciting. You're gonna get 7 minutes for this one. Because yesterday I realized that we couldn't just easily share files. You see? You get an extra 2 minutes because you're gonna have to manually type in. Oh, what's that? I know. It's okay. But you are going to, you have 2 extra minutes to do it. Capitalization does count. I want you to get that file. Name it seeks.fasta instead of the fungal seeks.fasta that it will come as a default. And then count the sequences, redirect that into a new file called seqcount. And then count the number of sequences that begin with this series of nucleotides and redirect that to the new file called gtag.
So that's the underscore.
Underscore, yes. You know what? Let me
Really?
make that bigger. How do you want it?
How did you want it?
Right here, task 1. Peaks out that.
Oh, sorry.
I wanted this all. Bigger. Going.
I I fell off my bed yesterday.
I'm sorry.
Yeah.
So you're using this as a screen?
Yeah. Yes. I tried.
That's pretty intense.
Yeah, I know,
That's
yeah.
just cool. Cool.
Yeah.
Thank you. Yeah, that's three underlying part.
Um,
Yes. Okay. Keep going for so you looked at the documentation for this, you'll see that on the fly, you can just rename the capital O flag. Speaks or what about FASTA. So you can give it the name like, hey, I know I'm about to download a file, but I want to crawl this. And then give it the URL. Okay, so I got seeks.fasta. I'm gonna cat that. And I'm gonna grab things that start with that. And I'll just throw in a -c flag to count the number of things that start with that. 2034. Redirect that to sequence. Okay. I'll cat feeds.fasta. And this time I'm looking for GTAGG starts with. So I'll do another count. Starts with GTAGG 1898. Redirect that. There are a couple of you that appear to have left this out, at least at first. That begins with get a slightly different number. If we look at here, you'll see that, yeah, it's popping up at the beginning of some lines, but also in the middle. So that's why you're getting different numbers. That you're getting some lines where it was just popping up in the middle. If you're searching for primer sequence, that having it at the beginning can make a big difference. If that primer could be real sequence that you care about out in the middle, it could be part of the gene. And you only want to find it if it's like at the end to chop it. Okie dokie. Well, last time we managed to download FASTA files or FASTQ files and then started looking at them and kind of looking at the anatomy of a FASTQ file. I'm going to go back to where I was in my biocomputing. Lesson 5. Okay. So I've got all my files in my phone. I assume that everyone remembers where you put yours and found them. Okay. There was another thing that we downloaded also, which was Yeah, so I've stuck it in scripts. It was interleave chop dot should. If it's not already executable, go ahead and make sure that that's executable and stick it somewhere convenient. So for me, I've got my FASTQ files and data, and then in scripts is where I stuck interleave chop
In your lesson 5.
in my lesson 5.
Okay.
Give you a second to kind of organize yourself. Interleave chop is a really dumb program I wrote. Doesn't do anything super useful. But it does two things simultaneously, really quickly, and really well. And what it does is it takes 4 positional arguments. The forward read, then the reverse read, and then the output file name that you want, and then the number of nucleotides to chop off at the end. So we're going to have to give this 4 positional arguments. We have to tell it what our forward read is, the complementary reverse read. Then we're going to name a file outputs and tell it how many nucleotides to chop. So we're going to say like, hey, do interleave chop, forward, reverse, output file, and then a number.
You like cutting from the.
We're cutting from the read. So we're chopping N nucleotides off of the 3' end.
Oh, okay.
Okay. There's good reasons why you'd want to do that. If you remember our FASTQ files, like the read quality just really started tanking at the end because Illumina is kind of like that. And so very often you will find yourself wanting to remove those. This is a very unsophisticated, stupid way of doing it, just saying like, take off 20, right? It's nicer if you can take off 20 if they're bad. So I wrote this just to be simple and click forward. So what it's going to do is it's going to take the forward and reverse. It's going to chop N nucleotides off of the end of both of those, and then it's going to stick them together in the same file, where each read alternates. So we're going to have the forward and then the reverse. Don't worry about this ugly awk code that I put together for this, but it works. Test it. Okay, so here I am in my lesson 5. I've got interleave chop living in scripts, and then I've got my data, all my FASTQ files living there. So if I want to call interleave chop, I say from here, scripts, interleave chop. And it's executable, so this works. If I run it by itself, it prints this handy little usage message. This is the kind of thing that you'll see as you start working with more and more programs. Is they write a little helper for you in case you use it wrong. They'll say, hey, by the way, here's how to use this. Okay, so the usage would be this, and then in our little like less than greater than the 4 position arguments. So read 1, read 2, output, and the number to chop. So let's do this for the first one, just to like try this out. So I'm gonna get up, get back here, and then I need to point it to a paired forward reverse file. How do I do that? From here.
You can like file like same beginning, the correct, the
It's
same.
gonna have the same beginning, but let's just do it manually. I just need to say, oh, it's in data. Hit the loud key a couple of times, see what options I have. So we'll go with 90, SO90, that's our first file in there. And then I hit tab again and it auto completes up to a point, and then it says, I can't decide. What do you want? Yeah, so looking at these, I'm just saying, oh, read one and read two, that's my order numbers. So I'll hit one there and then autocomplete the tab. Okay, so we gave it our first positional argument. Our second positional argument would be SO90, S9, L01, R2. So I'm gonna point that to data again. R2 tab. Then we need an output file. Did you do chmod plus X? Let's see. Okay, so you're in lessons.
Oh, those I see it on
Yeah.
those.
So let's go in. So so
Okay.
you've just got it here, not in its own script stuff. So. Delete chop. I think you changed anything in that file. So. Yeah. Setups.
I know, I used to do this a lot, but then I don't know.
Let me see if my file sinks.
Something, it's an
Right.
example. Like say something.
I've got an idea. MD5 sum. Scripts. Interleave job. Okay. If you do an MD5 sum on your version of interleave chop. See if the files are not.
Yeah, it's
Not the same. Okay. So what I would do for you is go back here to this lesson and this first line is the wget interleave chop. So remove yours with RM. And then run that first line from lesson 5 and it'll get you. I don't know what happened. It could have been like a corrupted download. Now you have to do chmod plus that. Yes, now it's working. So it's just giving you like information. Right. So the usage is showing us basically. Okay, you're gonna call this thing, give it a forward. If we give it a reverse with like the wrong headers, it's gonna get angry. So it's gotta be the same sample number. And then we need to give it an output name. for position 3. What should we call it? Mom? I don't know. What do you want to call it?
Yeah, that's good.
Well, let's be a bit,
That's.
yeah, okay, so here's the thing, yeah, I know your mom is fun, but then we lose information, like, we've got information stored there, that's a sample number. That we sent into the sequencing center, it lines up with our metadata table and an actual physical. Like, tube sitting in a freezer somewhere, so, yeah. S090 chopped,
But also kind of like just a mini question,
dot
like,
fast key.
would it be helpful to like have it start with like chopped versus like, that's like when you do like the tap and click, or like you do like the start after this faster, that like is like one more advantage.
I like how you're thinking about this, but it's actually not, it's not a hindrance because we can do star chopped.
It's like, would there ever be a case where we would want like only the chopped, or we'd want all
Yeah,
three
for
of
sure.
them, so we would want.
But we don't have, it doesn't have to start with something for us to pattern match.
Okay.
And so as long as we are naming stuff systematically, I think having this is the common way for a reason, I think, is having your sample number be like the first thing, and then information about like what steps has gone through. We've got the R1 and the R2, so we could easily just pull out, give me all the R1 files by saying star underscore R1 underscore. We can do the same thing with chopped. So we've got an output, and then we have to give it a number for our fourth argument. Let's do 200. And run it. It's done.
Wait, why did you think that, sorry?
That chops off 200 from the 3' end. Yeah.
Instead of an amount.
Whatever number. Now, in reality, a program like this, there's lots of programs out there that do this kind of chopping thing. They do it a bit more sophisticated, but often they will say, like, how many would you like to cut from the end if they're bad? You know, where would you get that number? You don't just come up with 200 and like pull it out of your ass, right? Like, you need to look at the quality scores and see, like, oh, on average, they look bad the last 15 or whatever. So then you would say 15. And so, like, those kind of decisions come from your data, but here we're just checking it out. So I'm gonna look around, I see SO90 chopped. It worked. Or you gave us a file. I'm gonna cap that. Looks like a fast queue. Every 4 lines. But there's a slight difference. Instead of all the forward reads being in one file, all the reverse reads being in another file, this is referred to as an interleaved FASTQ file. We'll find these in the wild. We'll find some programs that require an interleaved output. It is, it's just empty. So let's see your script. So you are calling it from data. I don't see a folder called data. So you're here. I'm looking at all your files here. So I would take out that data and just do / in front of both those files. Yeah, so that you were just, and this isn't abnormal, you're just typing what I typed, right? And I started with / data. That's where my files live, because I stuck them in there. If I was sitting in data and I look around and I see my files, this is not going to work. first off, I'd have to go back one to find my scripts, then use interleave chop. And then if I use this, there's no data present, so I have to say, oh yeah, I'm right here. Here's where my files are. The interleave chop script is actually back one in the parent, and then in scripts. So you gotta like, that's why it's empty. It worked, it just didn't.
So I will. Well, I'm on.
You're in the, yeah, so. Yeah, script, interleave chop. And then the files are here, and so you just call them directly. Yeah, hold on. Error. R2 has fewer records than R1. Yeah, so that's a little test I built in. And that shouldn't be the case. Running the script. S90, S9. Okay. Oh yeah. It is. There you go. Yep. Another friendly reminder that tab complete is your friend. Typing things manually like I made you do for your quiz is bad. Always, because you will forget to capitalize something and spell stuff out. And so I'm gonna go back up and I'll just do head on this. So we can see the first couple headers. In particular, look at this header and then this one. They're referring to the same physical spot on that sequencing chip. So that's addressed here. This is the serial number of the sequencer and then the location on there. Crazy notation. It's got millions of pixels. So this is referring to a pixel. And then it's saying 1N09. 2N. So it's going forward read, the exact complementary reverse read, then the next forward read, then its complement. So that's interleave. So if we had 10 sequences in our forward and 10 in reverse, how many sequences should we have in the interleave version? 20. Yeah, so it should be doubled. And they should be 200 shorter than their parent units. Okay, well, that was our command. And even with the tab complete, it's annoying. If you had, I don't know, 1,000 of these files, you would not want to do that one. So how could we do it? A for loop. What's that? No, I think you're right. I think a for loop might be the way. But it's going to be trickier than a for loop we've seen before because so far we've seen a for loop and we give it like a list of identities to become the variable and go and do this, but we can't do that here. How are we going to do it with a forward, a reverse, and an output file and then a number? What do we loop through?
Make process other substitution stuff.
Some substitution stuff. I mean, it's getting close to the weekend. You're going to have to help me understand what you're saying.
We have to look through the R1 and 2.
We got to loop through both. For loops can't do that.
So I know the one look at every file.
Look at every file. We can't tell it to do, well, we can tell it to look at every file. But it's gonna have the R1 and the R2s all mixed up with each other. Okay, so
You messing for loops and then.
you could do a nested for loop. That is gonna be really annoying. And you still won't have an output file. So you could do a nest, you could do a for loop and inside the for loop put another for loop. It's like basically an if statement. If this has an R2, then assign it to this other variable. Bullshit. I don't want to do that. Don't make me try.
Like, is there any way to like combine the two files, and then when you call it, you like do like different ranges for the first two original elements? So it's like the second half of it and the first half. So then it's like one file, but it's like, so it'll be like one in the range, but then. Like we just.
I see where you're going, but we still wouldn't have the output, the SO90 chopped.
Mm.
Like that doesn't live anywhere. But we don't have SO90 and SO91 chopped, like so we can't loop through them. What we have are our files. All right. So maybe like this substitution thing that you're talking about.
Yeah, like, yeah.
So you gotta help me here.
I don't know, that's all I have.
Okay.
Substitute.
That's the right track.
Some kind of substitute.
Okay, yeah, some kind of substitution. So let's look at this. We've got some commonalities between our forward and reverse. This will always be the case. And we've got a commonality here because we're being nice people and naming this not your mom, right? And then 200, we're going to do that for everybody, so that doesn't matter. What's different? It's the R1 and the R2. So if we could loop through all the forward reads and then somehow assign another variable that's like, hey, whatever the variable is, I want you just to replace underscore R1 underscore with underscore R2 underscore. So we can kind of do that substitution. And in Bash, this is called parameter expansion. And in your lesson is right here. Woohoo! See how I did that? Pretty slick. Okay. So the idea here is that we are going to change out that R1 for R2. Now there's a lot of parameter expansion stuff, and I want you to look through these and kind of play with them, but let's just do it here. Oops. Okay, so I'll start a for loop for I and mine are in data. How would I get just the forward reads? So I don't want to loop through forward and reverse. I just want like one file for each. The weird like asterisk underscore R1. Yeah, I'm gonna do that asterisk R1 underscore asterisk. Okay, so this is saying for all the things in data that start with whatever, have an underscore R1 underscore this. Let me back up and just do a sanity check. There they are, just my forward reads. So I'm going to be looping through those. So I'm going to say for I and those. Semicolon. Do what? Now here's where we can start actually assigning variables with this expansion idea inside of the for loop. This is really powerful, is that we can use the stuff we're looping through to create new variables based on those names. So right now, I would be equal to that string. So I would like to make, just for convenience of reading, a new variable called forward equals $I in my curly brackets. So that's In my for loop, we're gonna make a new variable called forward. And it'll be the current value there highlighted. I'm gonna make another new variable after a semicolon. It's a new command. I'll call it rib. Okay, and it shall be forward slash underscore R1 underscore slash underscore R2 underscore pattern replacement. So just like in like set or graph or translate or whatever, here in this expansion, and we can do this because we're doing it inside the curly braces. We can say, hey, this variable, which is I, look for underscore R1, replace it with R2. And then that will be red. Neat. Okay, new command. I'm just gonna echo $forward and $rev just to check and see. And then I'll say done. This should loop through all those and then print out the values of each of those variables. Holy shit, it worked. We're like halfway there now. So we've got a way to assign positionally our forward and our reverse. All we need now is that output file. So another parameter expansion thing is we're going to take that forward word here, and instead we just kind of want to chop it off after SO90, remove all that and change it for what? Chopped.pasq. Okay, I'm going to the table here. So what we did last time was this pattern replacement. And we just replaced the first occurrence. That's good behavior for us right now. If you wanted to replace every time it's season R1, you put 2 little slashes. Yeah. Oh, yeah. Yeah. Everything is done. That reverse. So we're in this. Yeah, yeah. That took me a hot second. All right. How can we do this? We want SO90 underscore chop dot pasq.
The mod, the placement.
Yeah, I think that's gonna be our thing. So look, here's this example. We've got a variable named foo. And it is abcdef.txt. And they're showing this parameter expansion foo, which is this, percent dot star. Remove the shortest match from the end, and then that gives us abc.pdf. So that found this pattern here, looking backwards from the end. It saw dot star, dot anything, it removed that.
Shortest versus longest. Shortest is the first one, across the longest is last.
Yes. So let's play with this. I'm gonna take the original file name here, copy it, and call it foo equals that. So it can be like. And echo will let us see the value. And I'll say foo, if I want to replace R1 with R2, that's easy. Just did that one. But let's try some of the other ones that were in that table. Foo, percent, or no, underscore. Underscore star. Oh,
Sorry, what is it?
this percent is right here. Remove the shortest match from the end. Okay, and it did. It found our first shortest sample dot pasq. So what do you think? That's getting closer. You want more of it? Yeah, I want more. How about the longest match? Percent. Ding ding ding. So that's the difference there, is like it first time removed this because it found this pattern. It was like, that's the first one I see, it's the shortest match. But also that pattern matches all of this underscore star. And that's the longest version. All right, so this table may look a bit Greek and confusing. I admit it does, definitely does, but here's how you actually find out what they mean by remove the shortest match. Okay, the only way is to try. Okay, so we're starting to build a little intuition, like that wasn't it, let's try this other one, there it is. And that's our winner right there. So we can use that. But I also want underscore chopped to be appended to that. So I'm just gonna add it here. I'm echoing this parameter expanded foo underscore chop dot pasq, and that's just absolutely beautiful. Okay, so that's what the brackets are all about. And when I told you before, like the curly braces are for safety, they isolate that variable, and then anything else you put after just gets tacked on to that variable, which is great. So we can say echo foo, chop everything after the longest pattern that you see here, and then add underscore chop dot pasq, and that's what we're looking for our output file. Okay. Yeah. We got to get back to that for loop. There we go. Okay, so right now it's looping through just the forward reads. And so it's getting like this as its first input. We're assigning that value to forward just for our sanity. I don't like to call it I. Yeah. I could have just called it forward to begin with. And then I'm making a new variable called rev. I'm taking that forward value, replacing underscore R1 underscore with R2. So rev will now be equal to this. And now all I gotta do, and then I'm just echoing those so we can see what I'm going to.
Why do you need metrics like that stuff?
Because I'm trying to find all the files in there in data. I don't care what they start with. And all of them, I don't care what they end with. This is just my way of saying all the files that have R1 surrounded by this. Yeah. All right, so now we need to make an out. And I'll add that right here after the forward. Out equals, and what should it be?
Value. Forward. And then the percentage. That's this underscore.
Underscore asterisk.
Yeah.
And then underscore chop dot asq. So now I can, just for my sanity, echo forward, reverse, and this new value out. L, yeah. Okay, so our for loop, by assigning variables inside of it, it now has access to those variables. It knows what forward, reverse, and out look like. I've previewed them myself because I don't want to mess up. And I see that, yeah, those look like exactly the sorts of things that I want to send to my program interleave chop or interleave chop, whatever. Okay, so instead of done here, now it's time to actually run interleave chop. And so for me, that is in scripts, interleave chop.show. And then it wants 4 positional arguments. It wants a forward, a reverse, an output file, and then a number 200. All right, I'm gonna take this whole little command here. And just so we're all on the same page, let's look at it one line at a time. So there's our for loop. Let's stare at this until we get tired and fall asleep. All right, somebody break it down to me in plain English.
For every forward, in your data directory, make a variable for that file, and then make another variable called reverse, where you're just replacing anything that has R1 and that the title of that file is R2.
Okay.
And then also make another variable called out, which is like the same thing except we're deleting everything after the first underscore, and then we're appending the underscore chop dot fast to do that.
Beautiful.
Tell the screen what the variables are, and then run our scripts with those variables in it plus.
Love it. The real work here is just this. Like that's what we wanted to do this whole time, is just run interleave chop on all these files. But we've got a bunch of them. This is the way to do it on a million files at once. So even though our for loop, the program we want to use requires like all these positional arguments, and they all have to have different names and stuff. We know that those names are all going to be based on the names of those files to start with. The forward and reverse are always the same thing, except in R1, R2. Sometimes it's just an underscore 1 or underscore 2, depending on what company you use. And then our output, we know that that's going to be based on the file name too. And so we can just use this parameter expansion, make it happen by assigning variables inside of the for loop. All right, this is good stuff, honestly. If you can understand this and get to a point where you can do it on the fly, you're like 80% of the way towards being a bioinformatician and can get a job pretending to be a bioinformatician. Like, yeah, I'm a bioinformatician technician. And we'll be like, all right, run this on all these files and they're done. Like, oh wow. Because they can't do it or they wouldn't be hiring for it, right? Okay. So honestly, it's pretty powerful, the idea of assigning variables inside of the for loop. And this parameter expansion is really nice built into Bash. Now, it does have like an awful lot of alternatives, right? There's more than this, but here's like the pretty useful ones that I find myself using. Especially this pattern replace, R1 and R2, so common working with sequence data. And getting rid of file extensions, so common, because we've got like some sample number dot fastq, and I always want to have that sample number dot log or dot out or dot bam or these other like commonly used files. And so just replacing that. So that's pretty neat. I'm going to go ahead and run this. It's done. So I'm going to go into my data now. I'm going to look at it, and there's my chops files. So I'll do head and 4. We'll look at the first, let's do first 8 of S099 underscore star. So we're just going to look at those 3 S099 files. Okay, nice and messy. But here's the chopped version. It's interleaved, read 1, read 2, and they're super short. Here's the first read, the forward. It's had 200 nucleotides stripped off the end of it. So in other words, I should be able to see this pattern right here, copy that. I'll pipe this to grep and paste in that pattern. And you can see, there it is from our chopped version. There it is. Yeah. And I'm just realizing that I had this pulled from the 5' end instead of the 3'. Oops, I told you wrong. So my auth code, I should have used GPT. All right. So it's chopping the front off, not the back.
I think you wanna do it. When I like ran for the like the usage. So, but not. Like I don't know how it's pretty.
Let's see your folder.
Yeah. So I'm gonna do this, I guess I should probably. for that. Like, possible.
Yeah, because, wait,
I would look at this one.
okay, there's all your data files.
So like, I think this is where I have.
Okay. So now your for loop. For I in data, there, now it's gonna find stuff. Do make the variables and then in scripts, chop. And it says it doesn't like it. You spelled out wrong. Yeah, right.
Okay, well, I mean, maybe I can go further on, I can put like the scripted.
R2 has fewer reads than R1. Okay.
Yeah, and then like.
Yeah, okay, so what's happening here
Mhm.
is I see S0909, so there's no underscore. Yeah, so in your reverse, you forgot to put the underscores on the sides of the R2.
Right.
So it was replacing underscore R1 and then so it couldn't find that file.
Mhm.
Yeah, so if you go up to that for loop, then just put the underscore on both sides of the R2. You're good to go. Yeah, these little like I forgot how to spell out, or I forgot the underscore, or I accidentally have it chopping from the front instead of the back of the read like I planned. I know exactly where I am, and that's just I put a P2 instead of a P1 in my script. We're dealing with computers, they're really stupid and they follow instructions exactly. They have no nuance. And so when you spell something wrong, it's just like, I did the thing, but it didn't do the thing. I don't know what to tell you about this. It's very demoralizing.
I think you can scroll back up to the script.
Yeah.
Because I put the underscores in, so it worked. So, what's this one?
Or let me bring up this version. So let's see. You're in data. Oh, that's your problem. You're in data. Yeah. So control C will get you out of that. Yeah, go back up. Now you should run. Like it worked. So you LS or you stuff them in. Yeah, so they'll be in data now, right?
Mhm.
So I don't see the
Yeah.
it looks empty.
Mhm.
Oh, so far it didn't run anything.
Oh, because we're doing that. That's good.
Yeah, so then you have to add this part.
Okay.
Yeah.
Oh, we're.
All right. Reflection time. Share your feelings. You need some more practice with like the substring removal. That stuff was confusing. It is. I have exactly two of them memorized, those two.
Honestly, those are the only two I've ever used in practice, like regularly. But I have used the other ones because they will come up here and there.
So which one was it? Is the last one?
The pattern replaced here and then the percent. I've used both of these. Okay, the shortest and longest from the end ones. I've also used the shortest and longest from the front. But far less commonly because almost always the sample name is like the first part of any file.
The time replacement is just the first one.
Yeah, and replace all occurrences I've never actually had to deal with. And you know what? It doesn't matter if you can look this up as long as you know that it's an option, like, and if you're Googling or whatever, you would just, the keyword here is parameter expansion. So you go on ChatGPT and start trying to explain your problem, and you'll have a tough time getting an answer unless you say, I'm using bash parameter expansion. Here's my variable. I want it to look like this. It'll spit out one of these for you. But that keyword is pretty key. It's parameter expansion. Honestly, isn't that like half the battle these days? Just knowing what you're talking about. You don't even have to know how to do it. Just need to know the language. So, Rosie, do you still need this up?
Oh, yeah.
Okay, and it's working?
Mm-hmm.
All right, more reflection time. All right. For the arch. Yeah, so more practice with it, but also this idea, and this is one I do want you practicing at home, is like setting multiple variables inside of a for loop. So loop through some list of strings, these character strings, and set variables based on them. Whether that's pattern expansion or just tacking things onto the end, and then just have it echo out so you can see what's happening. So I can say for I in star underscore or star chopped star do echo I done. All right, so there's my things that I'm working with. Do echo I underscore your mom done. All right, so we can just tack things on the end of it. You don't have to do replacing. This is another common pattern. So you'll have, sometimes you'll see a file, and then this isn't bad practice, called like S090 R1 raw fast view. Okay. Then you'll see that file. And then you'll see that file. Remember that file extensions don't mean anything. It's up to you, the user. And so I sometimes do this. I work with people that like this kind of habit of every time you do something to the file, you're just tacking on a new appendage of what happened. And so if I see a file working with these people, it's great. I'm like, oh, that's the log file from the extracted, cleaned, raw reads. Like, you can just kind of work that. That's nice. And I feel like they probably do that because they never learned the pattern expansion substitution stuff, and they just like tacking on new thing. But it also kind of works. Kind of works pretty well. And so play with this inside of the loop, assigning new variables and just echoing them. That'll get you there. Man, not found. Shit. All right. So I've got those. We've got the originals, and then we've got the chopped versions that are interleaved and I've had 5 prime, not 3 prime, removed from them. Yeah,
And I think this for, again, you're saying like for everything that contains the.
yeah, for everything that contains the word chopped, echo that thing, and then ended with underscore them all.
And none of the lives were anything like this.
Oh, so why, okay, so the asterisk, chopped asterisk is because I'm saying 0 to infinity of anything. It'll have the word chopped somewhere, and then I don't care what it's named after, and so it'll find that. I could have said chopped dot fescue, and it would have done the same thing, but I'm lazy. Also, not safe, but I could have said star CHO star, and it probably would have just found these files. The more specific you are, the more safe it is, but. Oh, right. I'm comfortable, knowing that I didn't have any files in here that had the word chopped that I didn't want to get. So. Mhm. Okay. So, cool. We use pattern expansion inside of our parameters, and we made interleave chop work for us inside of for loop. Next up, and there's no way we're going to finish today. That's all right. We'll pick up on Tuesday. Because I feel like better use of your time between now and next class is practicing the parameter expansion, practicing for loops, rather than kind of trying to go through the rest of this lesson on your own. But we can get this part at least. We can get this installed. So if you copy this, that's the code. It'll get it installed for you. This is the easiest bioinformatics program to install of all time.
We want to in our programs.
Yeah, and so if you do the whole thing, it'll just take you to it. The CD programs that wget. This one's easier to install and a little bit dumber than CTK, but it can do some things that CTK can't. But there's a place for both of them. What I love about this one is that it's great for teaching because there's no tricky install. It's just a file you download, you extract it, and it's there. That's it. So it's a single binary. So great, my system on top. Log back into Bora. Go to my programs, and there it is, seek kit. Yours green with an asterisk next to it, and a nice X over here on the side. If not, you know what to do.
Once we.
Yeah,
Should we get rid of it? Like what we got rid of or just leave it?
so that thing, I've left mine here
Okay.
to show you. So that tar.gz is a tarball, gzip tarball. When you extracted it at that tar xdbf, it just put this file there. And now you don't need this anymore. So I'm gonna remove that just to clean up because it's 8 megabytes of garbage I don't need in there. So I'm in my home programs. I see seek kit. Now I'm going to go back home with a good old CD, and I'm going to say which seek kit. And it gives me a spot. If it doesn't give you a spot, that means your programs is not your path. Which your mom. know your mom anywhere in here, right? So it didn't find anything, which CKIT did. Were all of you able to get that? You should, because we put programs into our path, and that's in our .bashrc file, so should be good to go. Cool. Yeah,
I have a question on, in terms of like the assignment I was doing today, like, I was confused on like, so if we already added the programs file into our path, why do we have to, like, why didn't TK work when we just added it to the folder? Why do we have to also add that folder's binary into there, into the path as well?
because path will look in, like, for example, here, my home programs is in my path, right? And it looks in here, and it will not go into any subdirectories.
Oh, okay.
It just sees these. So if you want, here's my seek TK. Seek TK. Oh. Seek TK. That's where the seek TK program lives. And so this also has to be in my path.
Okay.
Yeah. That's a good question.
I was super confused like that.
Yeah, path doesn't recurse into subdirectories. Okay, so from anywhere in our terminal now, we should be able to say seek kit. And it's just gonna say, hey, did you mean to actually do something? Here's how you do it. Seek kit and then the command. Commands for basic operation. Commands for format conversion. Commands for searching. And for set operation. All right. So this is the other 20% of being a bioinformatics expert. It's figuring out how to use new programs. You can do parameter expansion and a for loop and put together a little script. Then all that's left is for you to be like, oh crap, I need a program that does X, Y, Z. And then GitHub says, here's one. Like, how do I use it? That's it. Once you know how to use it, well, here's one. Huh. Convert, so we can convert those quality encodings between Sanger, Solexa, and Illumina. Convert FastQ to FastA. Let's just try that one before we leave. So I'm going to go back to my lesson 5. Biocomputing. Lesson 5. Seek kit FQ to FA was the command. And it's like, hey, what file are you talking about? Okay, well, it's in data SO99 chopped .fastq. Oh, and there it is in FastA format.
So just converts a fast to fast.
It gets rid of those extra lines, the little splitter line and the quality scores. So that's how you use CKit is CKit and then some set of subcommands, just like git clone and stuff, git adds and stuff. Here, CKit comes with a whole bunch of different stuff, one of which is that the kit got some flags, but in general, it's just like command, subcommand. Or the first N FastA or FastQ records. That's actually super handy. Especially if you don't know whether it's a FastA or FastQ ahead of time. It will determine that for you and give you those records. You don't have to keep track of like line numbers and all that kind of stuff. Fish, graph. It's got its own graph. It does. It's got a built-in graph, kind of like what we're used to using, but optimized for DNA sequence files. Look at this, it allows mismatches. Can be very handy if you know there's a pattern in there and you're looking like, well, there's some SNPs, some single nucleotide polymorphism at this position. I don't know what it's going to be. The stuff around it, I know. See kit graph will find it for you. Okay. We'll end it there for today. And then when we get back on Tuesday, we're going to use what we did with our for loop. We're going to turn that into a script. We're going to do some stuff with seq-kit, turn that into a script, including the download part. And then we're going to write a pipeline that calls 3 scripts in a row. And then you're officially, like, you get a sticker, you're a bioinformatician. Where the semester will go after that is putting this to use as we start submitting big jobs to the cluster. So that's where we're headed. I hope you're having fun. If not, I really care. It's too late to drop.
So we should, we're like, when like 5 or